So we've almost caught up with what the others were doing last week, and today we're going to be solving trigonometric equations that can be made easier by using the addition formulae. So we'll see how that goes. So here's the first problem. Write it down. Have a little think about what might be the best way to go. We've got cos, we've got sin. We're going to be able to use the cos addition formulae here because we've got the angle and that. So that's the first thing to do, to write down the formula. And obviously you can go to the booklet for this one, the formulae booklet. So you'll have this in the exam, and it's cos A cos B, but then when it's minus on the cos one, it switches the other way round to sine A sine B. So we're going to be using that within this. Now you've got to be careful, there's a coefficient of 4 there, so that means that that's going to become, so 4 cos theta minus 30 is going to be identical to 4 times cos theta cos 30 plus 4 times sin theta sin 30, and that's equal to 8 root 2 sin theta, which was the other part of our equation, wasn't it? So we've got to try to move all of this out. How are we going to get it all into one thing now? Could it, when you've got a mixture of coses and sines, it's sometimes about getting rid of one of those. It's sometimes about trying to make tan as well. But the first thing to do is to think, what can we know here? And we can know cos 30 because cos 30 is one of our known values. You can just whack it into the computer. They give you root 3 over 2. So we can rewrite this out as 4 times root 3 over 2 cos theta plus 4. Sin 30 is a half times a half sin theta is equal to 8 root 2 sin theta. Then moving on from that, we can just cancel that down, and then I'm thinking, let's get all the sines over to one side, because if you've got the sines on one side you can divide by cos. So I've got 2 root 3 cos theta on this side, and I'm going to be taking this away, so I'll start by writing down what I've already got on the right hand side and take away 2 times 1 is 2 sin theta. Now in order to get the tan we need to only have one term with sine theta, and we can do that by factorising. So that's going to give us on this side sine theta outside the bracket, and then 8 root 2 take 2 inside. I'm going to want to divide by cos theta, aren't I was saying. So that would leave me with 2 root 3 there. And I haven't quite got tan because I've got this bit in here, but I can divide both sides by that, can't I? And that would give me 2 root 3 all over 8 root 2 take 2 is equal to sine theta over cos theta, which is in turn tan theta. So that means I can now find out what the angle is by doing the inverse of tan to that. So theta is going to be tan -1 of 2 root 3 over 8 root 2 take 2. You can whack that all in the calculator, and this is what we should get. Make sure you're in degrees mode, of course. So that gives you 20.4 degrees to 1 decimal place. But we need all the values between 0 and 360, so we'd better have a quick look at the tan curve. And 360 comes in there, doesn't it? 20.4 4, so that's 90 degrees at the asymptote, isn't it? So that'll be about there, and it appears again there, which is another half of your 0 to 360, another 180 degrees on, because that's how often you get a new cycle of the tan curve. So that gives us plus 180, so our final answer is going to be 20.4 degrees and also 200.4 degrees. Right, here's our second problem. So pause it and have a go if you don't want any spoilers at all. If you'd like a little bit of help, you're going to be replacing cos 2x with something using your double angle formulae, but remember there are 3 different versions in cos 2x, and we're wanting to end up, because you've got a single cos x here, I would say you're going to want to try to end up with a quadratic, so you're looking for cos squareds, so give that a go. And so what we should have, we're looking at cos 2a being identical to 2 cos squared a take 1. So we'll pump that in here first of all, so we'll have 3 and then 2 cos squared x take 1 inside the bracket, take cos x plus 2 equals 0. Expand the bracket, gives you 6 cos squared x take 3, take cos x plus 2 equals 0. Tidy that up, gives us 6 cos squared x, take cos x take 1 equals 0. Let y equal cos x, and we're dealing with 6y squared minus y take 1 equals 0. When it comes to factorising that, just think about the fact that you've got 2 numbers multiplied together to make -1. They're going to have to be +1 and -1. And then we're thinking what combinations of y. So it's 6y and y, or 3y and 2y. As we're only ending up with -1, I think we want our 3y opposite the positive and our 2y multiplying by the negative gives us those. So we can say that y equals 1/3 or y equals -1/2. And as that was cos x, we can then come over here and say cos x equals 1/3, cos x equals -1/2, and then use, so x is going to be cos to the -1/3, it's also going to be cos to the -1/1/2. Then you need to find those angles, draw your cosine curve for 0 to 360, and see how you go there. So have a go at that, pause the video because I'm just going to put my solutions on in a moment. Although before you do, I'm hoping some of you may have spotted a mistake. Just as I started to work this out, I realised that plus times, I need a negative, don't I? So I actually want the 3y times the negative. So this one should be 3, this one should be 2, which just means I'm going to have -1/3 or +1/2. So that's going to make a little difference over here. So we're going to have -1/3, we're going to have +1/2, and that's going to be giving us, what will it give us? It will give us 109.5 degrees for that one, and 60 degrees for this. Okay, now pause it and sort out the rest. And so what we should have is 60 degrees, 109.5, 250.5 and 300, because with the cos curve to get it balanced out, you're going to be taking your initial values from 360 because it's nice and symmetrical around the 180, isn't it? Great. Okay, we've just got 2 to go. Great, so copy this one down, have a look at it, see what you can do. As ever, we've got tan 2y, so this is the bit that we're going to need to affect, and we need to be thinking that tan 2y is identical to 2 tan y and 1 take, isn't it? On the addition you take, on the take one you add tan squared y. So that's what we're going to plug in to here. So that's going to give us 2 brackets 2 tan y all over 1 take tan squared y, and we're going to times that by tan y because that's there, and that's all equal to 3. So expand the bracket first of all. It's going to give us 4 tan y, but if I also times it by that tan y, that's going to give me tan squared y on the top, isn't it? Over 1 take tan squared y is equal to 3. Now we don't like the stuff being on the bottom, so if we multiply throughout by 1 take tan squared y, we're going to get 4 tan squared y is equal to 3 brackets 1 take tan squared y. I'm going to put some ink in my pen, see if you can finish that. Pause it before I carry on. Right, so now I'm back here, tan squared y, expand the bracket, gives us 4 tan squared y equals 3 take 3 tan squared y. Add 3 tan squared y to this side, gives us 7 tan squared y equals 3. Now it's not your normal sort of quadratic that you're going to be able to solve by factorising, because we've only got these numbers here, and I can divide by 7, it's just going to equal a fraction, so we can just root that. So tan squared y is going to be 3/7. So our tan y is going to be plus or minus the root of 3/7. So we need to do the inverse tan of both of those. So y is going to equal tan take 1 of root 3/7, and it's going to be tan take 1 the negative 3/7. And if you pop in this first one, that should get you 0.58, and if you pop the other one in, that gets you negative 0.58. Now that's a bit of an issue because we want values between 0 and 2 pi. Now, if you didn't get this, by the way, you're probably still in degrees. So there's our tan curve, asymptote at 90 and 270. But because we've got this negative 0.58, it's going to need to continue down to about there. Now that means that the actual values I want are there, which is 180 degrees on, or pi further on in terms of radians, and then another pi on there, and 0.58 there plus pi. So we're going to need 0.58 plus pi to get that one, and negative 0.58 plus pi to get there. So that should give us as our final ones 0.58, then this one plus pi gives you 2.56, 0.58 plus pi gives you 3.72, and 2.56 plus pi gives you 5.70. And we've got just one more example to go, so it's a bit of a heavy one this week, I know, or today, but there you go. Here's our final problem, and it starts off with a show that. And to show that is going into a shed load of signs over here. So how do we get a shed load of signs? Well, let's start off by treating this as your normal addition formula. So write it down. You might want to have a little go. Right, so some of what's going on here. We know we're going to be using this at some point, but first of all, this is the addition formula here, isn't it? So we're going to write out the whole of the addition formula. We can say that sine 2a plus a, using the normal addition formula, would give us sine 2a cos the other angle plus sine a cos the first angle 2a. And now we're going to be putting in the fact that we know sine 2a is 2 sine a cos a in instead of that. So we can say 2 sine a cos a, that is just that bit there, times cos a, plus, now we're going to have to replace this cos a. Now if looking at what we're trying to make loads of powers of sine. So the cos 2a identity that gets us there is the one where we've worked it around a little bit, and we've got 1 take sine squared a. So I'm going to pop that in instead of cos 2a. So plus sine a times by 1 take sine squared a. Then I'm going to clean all of this up and expand that bracket to give me 2 sine a cos squared a plus sine a take, oh hang on, a mistake there, isn't it? It's not 1 take, it's take 2 sine squared a, 2 sine squared a. So that'll give me minus 2 sine cubed a when I expand that. Right, so now before I clean this up, I've got to get rid of these cos squared a's, and I'm going to be using again the fact that we know that cos squared a is 1 take sine squared a. So that will give us 2 sine a bracket 1 take sine squared a, and we'll just keep this other stuff bubbling along there. Expand the bracket, 2 sine a take 2 sine cubed a, add the sine a, take the 2 sine cubed a. Take your time though, now it's just a little bit of simplifying, and that gives us 3 sine a, negative 2 and negative 2 making negative 4 sine cubed a, which is the right hand side. So at the beginning here we could have said left hand side is identical to that, because 3a is 2a plus a, isn't it? Okay, great, that's that one. In fact, that's all of them. So now all you've got to do is a whole, but in fact I don't think you need to do that many. I'm going to take some of these out. I'm going to take out 8 and 9 and 12. If you can do those 6, that will be more than enough. All right folks, see you tomorrow.